So 1.5, we're going to learn about combinations of functions. So we're going to be given two functions, and we can either add them, subtract them, multiply them, or divide them. So looking at our first example on the right, we are finding the sum of two functions. So it could either look like this one here, where it says f plus g of x, which is the same thing as f of x plus g of x. These mean the same thing, it's just written two different ways. So when we are asked to add the two functions together, f plus g of x, we just want to take f of x and add it to g of x. Just add them together. So f of x is 2x plus 1 plus g of x, which is x squared plus 2x minus 1. And then we just want to combine like terms. So I'll start with my x squared. What would come next? Plus 4x, because I have 2x plus 2x. And then 1 minus 1, these would actually cancel out. So our f plus g of x is x squared plus 4x. So we just add the two functions together and simplify where we can. The next part of this question says, then evaluate the sum when x is equal to 2. So this now wants us to find f plus g of 2. So we're just plugging in 2 for our x's. So I'll have 2 squared plus 4 times 2. So all I did was plug in 2, because it told me to plug in 2. It said x is equal to 2, so I plug in 2 to my x's. So 2 squared is 4. 4 times 2 would be 8, and 4 plus 8 is 12. So f plus g of 2 would be 12. So if I plugged it into f of x and then plugged it into g of x and added them together, you'll get the same thing. So you could do it separately and add them. This tells us that we add them, so plug it in separately and then add them together, you'll get 14 as well. So we're given the same two functions. Yep. And now it asks us to subtract them. So f minus g of x, we take f first, so that'll be 2x plus 1, and then we're going to subtract g of x, so x squared plus 2x minus 1. What do you think I need to do first to simplify? Distribute. Anytime you subtract, you're going to have to distribute. If you have more than one term in your second function, so here we have 3 terms in that g of x, so I have to distribute that negative sign to everything behind it. Don't forget to distribute, because then that'll give you a different answer. So I have minus x squared minus 2x plus 1. And then now I can combine like terms. So I'm going to start with my highest degree, which is negative x squared. 2x minus 2x actually cancels. And then I have 1 plus 1, which would be 2. So all I did was combine my like terms. So my f minus g of x is negative x squared plus 2. Next, I want to find f minus g of 2. It tells me I'm going to plug in 2 for x. So I have negative 2 squared plus 2. So 2 squared would be 4. That negative stays on the outside. Plus 2. So negative 4 plus 2 would be negative 2. So my f minus g of 2 is negative 2. So all I did was plug in 2 into my x's. Again, if I wanted to plug in 2 to my f and then to my g and subtract them, you'll get the same answer. So you can plug it in separately and subtract the 2. Or you can plug it into your f minus g of x. Notice how f minus g of x, we have an x here, we have x's in our answer, and f minus g of 2, we have a number here, so our answer is a number. So that's kind of like a common mistake people will make on a test, is that they end up having a number for their f minus g of x. You'll have x's in your answer when you're not plugging anything in, it's just x. So you should have x's in your answer for f minus g of x. Any questions here? All right, number 3. So here we want to find f times g of x. So the product of the two, we are multiplying. So f times g of x. I'm going to take f of x, which is x squared, and multiply it to x minus 3. How do I multiply these together? Distribute, perfect. So I have x squared times x, which would be x cubed, and x squared times negative 3 would be negative 3x squared. So my f times g of x is x cubed minus 3x squared. Next it says evaluate the product when x is equal to 4. So I'm going to plug in 4 into my x's. So I have f of g of 4. So this just tells me I need to plug 4 in. So I have 4 cubed minus 3 times 4 squared. So 4 cubed would be what? 64. 4 times 4 times 4, 64. And then we have 3 times 4 squared would be 16. And what's 3 times 16? 48. And 64 minus 48? 16. So my f times g of 4 would be 16. So here we're finding the quotient of two functions. And then it asks us to find the domain. So I'm dividing f divided by g of x. So f is square root x, and g is square root 4 minus x squared. So I can't simplify this. So this is my f divided by g of x. Next thing I want to do is find the domain. So to find the domain of a combination function, we have to check the domain of f, we have to check the domain of g, and then we have to check the domain of our entire function. And our domain of all three of those, what overlaps, is our domain for f divided by g. So first, let's check our domain for f of x. What number can I not have for x? A negative number. So this could be, can I include 0? Yeah, so 0 to infinity. It can be any positive number. If I put that on a number line, put that down here. Let's say 0 is in the middle. On a number line, I would have a closed dot at 0, and it would go to the right to infinity. So I could include anything from 0 to infinity. Now let's check the domain for g. So here I have the square root of 4 minus x squared. What can I not have under my square root? A negative. So I want this to be greater than or equal to 0. So I have 4 minus x squared is greater than or equal to 0. I would solve this just as if it were an equal sign. So I can add x squared to the other side. So 4 is greater than or equal to x squared. Then what would I do to solve for x? Square root both sides. What do we have to remember to include whenever you take the square root of both sides? Awesome. Plus or minus. So the square root of 4 would be plus or minus what? 2. So plus or minus 2 is greater than or equal to x. Now I actually have 2 values here, so just to really understand where we're talking about on the number line, I'm going to make my own separate one just for my g function up here. So I have -2 and 2. So I'm either talking about the values in between 2 and -2 or outside of 2 and -2. And I can test that by plugging in numbers in between and outside. So I could plug in -3 to test if values to the left of -2 work, so less than -2. I can plug in 0 to see if in between these values work, or I could plug in 3 to see if values greater than 2 will work. This should be +3. So let's plug in -3 into our function. So I have the square root of 4 minus -3 squared. So this would be 4 minus 9. Is 4 minus 9 positive? Nope, it would be -5. Can I take the square root of -5? No, so to the left out here does not work. Let's plug in 0. So now I'm going to test a number in between to see if in between -2 and 2 works. So I have 4 minus 0 squared. So this would just be the square root of 4. I can take the square root of 4, so in between works. And then just to really be sure, I'm going to check the right side also. So let's plug in 3. I have 4 minus 3 squared. So again, this is 4 minus 9, which would be -5. So that doesn't work outside. So in between -2 and 2 works. So I'm going to put those points in my number line down here. Yes, question? And the last thing I want to check is my domain of my entire function, f divided by g of x. So when I have a fraction, what can I not have here? So what can I not have in a fraction? We know we can't have a negative under our square root, but what else can I not have when I have a fraction? 0 where? In the denominator. So my denominator cannot be 0. So I also have to check my domain when the denominator is not 0. So 4 minus x squared cannot be 0. So I can square both sides. I'm just solving for x, so cancels out there. 4 minus x squared does not equal 0. Add x squared to the other side. So 4 does not equal x squared. Take the square root. So what can x not equal? Plus or minus 2. So actually, where I put closed circles here, I would need open circles. But it can be anything greater than, kind of technically, I'm just going to say less than for now, even though we know it can't be 0. But where my domain of this function comes from is all 3 lines have to overlap. So the only point where those 3 lines overlap would be from 0 to 2 here. Am I including 0? Yeah, because I don't have an open circle here at 0, so I would include 0. Can I include 2? I can't because I have an open circle here at 2, and it has to be where all 3 lines overlap. So even though this is a closed circle, Since I have a gap here, I can't include 2, so it would be a parentheses at 2. So this is my domain. So it has to be where all 3 lines overlap. So the only time we really need to check our domain is when we have square roots or when we have fractions. Because my square root has to be greater than or equal to 0, whatever's inside of it. And in my fraction, the denominator cannot be 0. So those are the 2 instances where you have to check your domain. For questions like example 1, my domain for both of these functions are all real numbers, and my domain for the addition part is all real numbers because I don't have a fraction and I don't have a square root. So if this question asks me for the domain, it would be all real numbers. So the only time you have to be careful with your domain is if you have a fraction or if you have a square root.